second one is the malware hardware side. We are starting the hardware actually based malware description, or let's say malicious description related to the hardware equipment. The first thing actually we are going to describe is the BIOS, the basic input output system, which is actually as the primordial technology, it is the integrated system managing the hardware in a computer or in given actually digital device, recognized for us as a computer, mobile, laptop, server, something like that. This system actually is responsible for managing the input-output flow, and it is actually installed on top of the motherboard mainly. And as per the first theories, it says that it is actually read only, it can only be utilized to manage the flow, more or less. We cannot modify. But recent updates and recent systems, they are bringing to light and commercializing the programmable read systems, or read actually versions from this BIOS. They were actually running on a read-only memory group of memories. Now they are running on top of a programmable category of read-only memories. Means we can actually flash, we can program and reprogram the content of those, let's say, equipment. Thus, the content of this system, since they are actually capable to be actually reprogrammed again and again whenever needed, there is an input to be passed to those systems. And this input, it is not to be controlled from the system side, from the operating system side, actually. It's not from the user side. So the security appliances on top of the system, they are not going to control this, those inputs for those actually category of systems, the BIOS, the basic input-output systems. Why? Because as we described the rootkit earlier in this chapter, it is something actually under the operating system. It is not in the control of the operating system. So it is something that comes in between the operating system and the hardware. It is the area where the kernel play. It is not something that the security appliances on top of the operating system, where they can actually play and they can control, they can adjust the filters. No, at all. So thus it is hard to control the input here. It's not the thing actually that we can do it easily, or the security appliances can do it easily. Thus it is easily. It's not as easily, but it is actually available. The vulnerability here regarding the infecting those BIOS systems, it's possible since the technology is setting this feature, which is the programming and reprogramming of those ordinary said ROM memories. Now they are no longer ROM, they are PROM. Any questions here, please?
Yes.
And since, I hope it's clear actually. And since we said that those ROM or those BIOS actually, they are systems that can be actually written and rewritten again, programmed and reprogrammed again. So there is an input, and thus as we can do it manually, those inputs, virus or malware can do that. Thus they can actually overwrite the system of the BIOS, actually the BIOS that it manages the hardware. What we can expect, it is something 100% similar to the rootkit, the one we described actually, that it is a rootkit which is actually controlling or infecting the kernel level, and it is hard to detect and it is almost impossible to delete. Is the same scenario here. Yet we can here, there is a chance here that we can rewrite. There is a chance. It's not that yes we can do it. No, it's not a confirmation here. Yet there is a possibility that we can rewrite the BIOS, and then we can rectify the malware. We can delete the malware if the overwriting the BIOS can solve that. So the chance, yes. At the same time, the chance of being actually infected also, yes, there is. The rootkit is an example. The rootkit is an example. But here, what we said here, that rewriting the BIOS will delete the malware, will not go. with the rootkit, because the rootkit is something that trespasses the BIOS. It's not something actually that we can delete it by just rewriting the program. No, it is much more persistent. The rootkit is more persistent than to be deleted when overwriting the program. So everything is on the motherboard only. Everything is on the motherboard only. The workplace is the motherboard. Another category of hardware that it is actually suspected to be infected by malware, it's a hardware, is the USB drives, the USB devices, universal serial bus devices, like the flash disk, like the very famous flash disk. It's not unique, but it's very famous. It's one of the very good examples that can be infected with a malware and can lead to spread the malware. Flash disk at the end of the day, or the USB drives, and when we take the example of the flash disk, it's a sort of ROM actually, but it is electrically and electronically actually erasable. Means the content of this flash disk is a read-only content, but we can electrically erase it and rewrite on top of it. So it is given the name EEPROM, actually EEPROM, electrically erasable programmable read-only memory. So at the end of the day, it's a sort of a ROM, means a memory that can be utilized to read its content only. But since we are able to electrically erase its content and rewrite on top of it, so it is to be utilized again and again and again. And thus the same way as we can do it manually, and malware can do actually and inject itself into a flash disk, and it can actually propagate whenever you copy, you as a user, you copy a content from the flash disk. Examples of malware actually have been actually spread due to the use of the flash disk. Countermeasures against the USB drives in general, the malware that can be actually spread or injected, or say the effects of a malware due to the use of the USB devices. Countermeasures, they can actually be classified into three groups. Whether we clearly disable the USB in hardware, means actually we open the case, a computer, and we take off the wires. Hardware actually disabling the USB drives. It means the computer will no longer be able to connect USB drives, flash disks. You take off the wires of the USB drives from the case completely. Yes. This is to be done computer by computer, manually. Second option is that from the device manager, from within the operating system only, we can disable. It's a sort of configuration from the operating system. We block the use of the USB drives, USB ports. From the operating system here. It's a configuration. Third solution, which is to use a specific utility responsible for controlling the USB drives. It's a third-party application, like the antivirus, but it's not an antivirus. It's a USB controller. It will control the in and out flow from and to a USB drive or USB device. Third-party application. Is it clear, please?
Yes.
Great. For the storage, as the technology here is imposed, we are having two configurations via which administrators can go. Whether we are going to dedicate a full space for storage within a network, within a workspace, we have a dedicated room, or we have a dedicated group of computers in a location. It is fully set for storage only in a network or in a company or somewhere. Storage area network. We talk about storage area network. The second configuration manner where actually work can be actually where work can be needed a storage equipment, a storage area, storage devices. Here we touch as many as we need storage devices. These is storage server. These are another storage server. These are another file server. All of them, they can be utilized for storage. Whenever we need another, we connect anywhere inside the network, inside the work plane. So here we talk about network attached storage devices. We are connected to the network whenever we need, and wherever we need from within the network itself, we connect another storage device. Here, no, in this configuration, in the SAN storage area network, no. To add extra storage devices, we connect them to this area only. It has to be connected to this area. And any other place in the network, it will not be considered. It will not be utilized. The drawbacks is that here, servers cannot communicate with every device, but they have to be actually configured to be communicated by every device manually. Everyone has to be configured manually. And here the drawback is that if one device is infected, all the others, they can actually receive another copy. The malware will propagate to all the devices in the storage area. If the storage area is infected, so all the devices are infected. Those are drawbacks. ألوف صوت واصل؟
نعم مستر.
Buthayna, check your mic, please. Check your headphone or whatever you are using. The same scenarios actually we describe, the same technologies we described in this chapter regarding the hardware malware or malicious configuration or malicious perspectives. In addition to the software malicious views, they are all still valid and to be a question to consider when we talk about mobile devices. The mobile devices, whether they are actually cellulars, phones, means, or laptops, or any other kind of personal digital assistants. All of them, they are to be considered with the malware we described, the malware, whether it is a software or hardware. All of them, they are still question of to be infected with. So the viruses that would actually infect a cell phone, they are the same that they infect a computer, yet with different versions. When we talk about a malware that would be utilized to hack a device, for example, we talk about the injection. So the injection will be actually running and be successful when we try to do it on top of a digital device. Still, the techniques may be different, but still the category of the technology, it is to be valid. So when you use a cell phone, for example, don't say that I'm secured or I'm more secured than when I use a laptop. Any questions? Who is raising his hand?
No.
Okay. Okay, the virtual environment or the virtualization context is a scenario via which we mimic or emulate or simulate a real environment. The virtualization, it's a scenario via which we emulate, simulate, or mimic a real environment. All of them, they are actually true. What does it mean? It means we are going to create a new device from a real one, but it's in a virtual environment. What does it mean, virtual environment? It means we do not touch it. We do not use it manually. We can reach it remotely. We can use it through a computer. We can use it through a digital device. We will have actually a processing unit. We will have a storage device. We will have actually a running space actually where we can actually a memory space where we can run all the applications we need. means as if you're having a computer, but it's not a computer. It is something that we can use it virtually to look like a computer. And it will give us all the capabilities of a computer. It will give us all the capabilities of a regular computer. So we virtualized an environment. Once we are able to run an operating system, and on top of which we run a group of software applications, and all of it's virtual. So we are virtualizing an environment. We will have actually all the resources available. When we virtualize an environment, we will have all the resources available. We talk about the storage devices, the processing capabilities, computational tasks, and all the connected resources, external hardware, all of them, they are available to us. We are not deprived from the environment. But the work is virtual. The environment is virtual. Operating system virtualization is a context via which we mimic an operating system to look like the hosting system. We'll have actually a new system inside an original system. The new is the guest, the original is the host. The hosting system will receive another guest, and they are actually looking like each other, but one is real, the other one is virtual. Same scenario when we talk about server, because the server is a soft and hard altogether. And when we are going to virtualize the server, we are going to create a copy, a hardware, let's say, representation, on top of which a software, which is the operating system, the server itself. So we are not bringing something new, just what is the thing we are virtualizing. Here we are virtualizing simple operating system, Windows 10, for example. Here we are virtualizing a server, Windows Server 2019, for example. There are technologies here. There are technologies that they enhance the virtualization for us as end users. The technologies here we're talking about the brands and developers. We take the example of the Microsoft Virtual PC, which is run through the Hyper-V. The Hyper-V is actually an emulator that emulates the real environment, that helps us to run virtually but using a similar configuration to a real one. Para-virtualization uses the extent. This is a third-party provider. The VMware is another type, which this is the one we use in lab, actually. This is the one. Both of them, they are third-party providers. They are companies that they actually given us the virtualization. They give us all the capabilities. They give us all the capabilities. They are third-party, yes, but they can give us all the features that we can use when we install an operating system in. Another category, but this is actually related to the Unix framework, which is running with Linux distribution. It's another virtualization, but system level, at the system level. So we use the Linux system to virtualize an environment from the system itself, like the emulator here, the Hyper-V from the Microsoft. The reasons behind of the virtualization is that we are, instead of buying a new computer, we may have an emulated environment that looks like a new computer, but without paying any, let's say, or with paying at least very small money for the RAM only. Or we may actually, if we do not need a big RAM, we may go for a new computer, emulated environment with zero budget. So we'll have an extra work, but without any extra fees to pay. And another view, which is actually the security. It would be isolated more than the original system, because the virtualized environment is an internal copy. this internal copy will run from within the operating system, the original operating system. So it is more isolated. So it is more secure. Actually, virtual environment that can be actually under attack because they are from within an operating system. So if the operating system is infected, those virtual environments, they can be also infected and they can receive the attack from the operating system, the host operating system. The host operating system, I repeat the word, the host operating system. Okay, there are technologies via which we can have a more flexible and more resilient work when using the virtual environments, and this is actually due to so many technologies, amongst of them the live migration and the load balancing. Means if we're having more than one virtual environment and we are trying to segregate the work amongst those machines, we'll be using a technology to do so. The machines here they are, sorry, the technologies here they are. We can talk about live migration. This is one of the technologies that help us to segregate the work in between the virtual environments. Or also we can use the load balancer or balancing technology as a solution to segregate the work between those live machines, and so on. So this is just a title of very famous technology that we can refer to not interrupt, the work, in order not to make a waiting list and put the parties be waiting for their turn in order to access the virtual environment or to access a resource or to receive a function or whatever. So to make the thing more fast and make the work within the virtual environment is more accurate and more actually responsive, we may talk about technologies to segregate the work. Great. Yeah, from within a virtual environment, we can talk about all the security features we know through the regular computer. If we want to install an antivirus, we can. If we want to install a firewall, we can. If we want actually to activate security features from within the operating system, also we can. If we want to just allow and deny some functions from within the operating system, from the control panel, administrative tools, all from what we are willing to do, yes, it is still possible. There is no restriction. It's not virtualized. Does not mean that it is with limited functions. No, it gives us the full functionalities. Remember, it gives us the full functionality. We can have all the functions active as per our need, as per the user's need, as per the business need, and so on. So everything is available. There is no restriction. So hypervisors, they are actually an emulator. Let's say they are emulators in general. They give a default virtualization to all the hardware available in the environment. Means if you're installing a hypervisor in your computer, so the user, at the end of the day, the user of the hypervisor will be having a copy of all the hardware connected to the device. If you have a printer, he will be having a printer. If you have a multi-core processor, he will be having a multi-core processor. If you're having a scanner connected to your hardware device, the hypervisor user will have a scanner visible to him also. And in addition to that, the security will be actually by default taking care in the sense of there will be authenticity to the use. There will be control of what to use and who is going to use. Actually, this is what we mean by default security set to all the hardware, to all the resources. Okay. The first view when we when we use a hypervisor is that we are going to have a dedicated machine for security. Here it is. The dedicated machine is for security. So it will actually take care of the security functions mainly. We will be having a full control through a security machine that will control all the activities from within the environment. So this is the hypervisor, and this hypervisor will be having the security control functions. Machine number one, machine number two, and the communication that happens in between all here. Those are two only, but we can have hundreds of machines. The control it is through the security machine. Another architecture. Here we are seeing the security as a plugin. We are seeing the security as a plugin. Means it is a function. It is an antivirus. It is a filter. It is a plugin that does a security function from within the list of functions available in the network or available in the workspace. Okay, we come to an end in this chapter. Unless you have any questions, please, we can go to chapter number 3. Any questions, please?
No, mister.
Okay, great. Great. So we pass to chapter number 3. Are you able to see the slides, please?
Yes, mister.
Yes, Mr.
Yes,
That's great.
mister.
That's great. So in unit number 3 now we are still continuing in the same process, which is the malware description and the countermeasures. But here we are talking about system-wise. We are not talking clearly about the malware, but we are talking about issues that we have to fix from within the operating system or the system software in general. Usually, the concerns of security or the issues to be controlled from within a system, it is tackling the updates and what to install, the updates and the installation activities. Concentrate well, please. Be with me. An operating system issues are related to updates and installs. Whatever you want to install, you have to control. Or whatever an update is required, you have to know and you have to control also at the same time. In the sense of what are the things to do inside an operating system? You are going to install a software application and you use it for a service. Or you are going to use the features of the plugins in the operating system for your administration or for your actually own business. Those two things, they can cause an issue, which are at the end of the day, you download it, or you install a plugin, or you are activating an update. Nothing more. Is this clear, please? Is what I just explained to you clear?
Yes, mister. Clear.
That's good. That's good. So
Clear.
from here, yeah, great. From this point here, to secure an operating system or to install an operating system, let's take the example of you are buying a new laptop, 300 riyals, i7, 16 GB RAM, 1 terabyte SSD. It's wonderfully running, and it is actually equipped with pre-installed antivirus and things like that. So that's great. So can you trust that? As a security and you as a student studying the digital security course, you'll never have to trust it. Why? Because you have to be aware of, are the updates controlled? Are what we install or what it has been installed already, the pre-installed antivirus, are they safe already? We have to be sure about that. So to be sure, we are talking about hardening the operating system. We have to harden the operating system. What does it mean? Means we are going to bring the operating system into a state where it is secure enough and works very fine. Secure and works, does not stuck and stop, for the purpose of preventing issues and the let's say related to data sharing issues. Okay, to do this hardened context, it is a matter of controlling the updates. All the updates, they have to be controlled 100%. What does mean control? Either to allow or to deny. You have to know what to do. You have to know what to do. It's not just update. Okay, let this one go. I have free internet, so let him update. No, it is not like that. It does not go like that. It's not acceptable at all. Then you protect your operating system. You protect your operating system against the buffer overflows. Buffer overflows is sort of an attack that attacks the storage devices, and mainly it attacks the volatile storage devices. What are the volatile storage devices? They are the RAM memories. And this attack actually utilizes more than what it is allowed, which is the buffer for every application. The space allowed for every running application is called buffer. And this buffer, if it is enough for the user, okay? Otherwise, the system has to go through the regular process to ask for extra space. If it does not happen and he uses extra space, we fall into the buffer overflow. So the buffer overflow, it's a context of overusing a volatile space, but without consent. Without consent. No more, no less. Great. The third aspect behind hardening an operating system is the configuration, is the management, means to correctly adjust what are the functions to use from within the operating system. Conclusion. We have to activate or disable or control in general the updates. We have to go beyond controlling the memory use, the volatile memory use for each and every single running application in the computer. We have to do that. There are functions from within the operating system only. We have to activate or disable. We have to know. And this is the purpose of protecting the environment against the buffer overflow, or in general, buffer overflows. Third scenario via which we have to, we can harden an operating system is the configuration. Configuration of what? Of the operating system itself. Because security set on top of an operating system is not only a third-party application to install. It's not an antivirus to install and that's it. It's not a filter, a firewall or whatever, an intrusion detection tool to install and khalas, we are secure. No. All the functions that they are related to mainly to the administration tasks, they have to be configured by you as a user. Means the allowances or the denials, they have to be done manually. This is it. This is what it is described under the configuration of your operating system. I'll immediately pass from this slide to this table. I'll immediately pass from this slide to this table just to bring you to a little bit of history. When you talk about the genuine operating system, general operating systems in plural, or the licensed operating systems, we talk nowadays about the Windows 10 as the commercialized one, with all the distributions under this Windows 10. And we talk about the prior copies or versions or distributions. The early age was only the MS-DOS. The early age during the 80s, it was only running the MS-DOS. At that time, only that operating system was dominant, and it was very famous at that time, and the unique, licensed, and genuine operating system running at that period. It was a command line based operating system. So this is a small history. What is the concern for us as security guys here is that the size and memory of this MS-DOS at that time was around 4,000 commands. 4,000 commands at that time. 4,000 سطر only. The early age of this operating system. Let's compare it with an operating system built at the date of the book, 2007, which is the Windows Vista. 50 million commands. Can we compare? It's a huge advancement. This is a complexity. I come back here. This is a complexity generated. This is an increased complexity in the operating system, which is actually leading to a new technology given birth. It's a new era of better life, yes, but this is actually another dark side that we cannot actually control easily. The increased complexity, yes, it brings technology through, but it brings something that we cannot control when you talk about management. Does not mean that we don't go for it. No, the benefits. I use the technology before I tell the complexity, because the technology we want, but the complexity we don't want. We need the technology, but we try to avoid the complexity as per our view. Remember in chapter number 1 when we described the antiviruses, we said that they have to be actually complex from outside and simple from inside. This is what we need here. We need the technology, the service, but it has to be actually as simple as it can be for use, not for security reasons, for use. I'll stop at this level. We continue next class. I'll stop at this level only with this view. I'll explain it more and more next class, inshallah. If you hear your name, please say yes. I'm going to stop the recording.